disclosing real-world attack scenarios that I have discovered during my work. So it should be a very interesting session. All attacks were using business logic vulnerabilities. Throughout the presentation, we'll be explaining what our business logic vulnerabilities are, and we're going to explain further. Before we start, allow me to introduce myself. So, first of all, I'm very passionate about cybersecurity, and I have chosen that career specific because I do love the idea of cybersecurity. I do love the fact that every day we are contributing to the life of the individuals and organizations and help them secure their services. So I'm really passionate about the field, and this is what pushes me to keep learning and helping the community and helps others to grow and grow as well. For that, I always contribute in multiple mentorship programs and community work beside my work. So what do I work? I work as a senior team consultant at Liquid C2, where I cooperate with organizations from all over the world, but particularly Africa and Middle East, to help them enhance their cybersecurity culture. I hold multiple certifications, and throughout my career, I was honored to receive multiple acknowledgements. The first one was in 2019. I was named to IFC Global Cybersecurity Influencers, and the latest one was this year, 2 months ago. I was honored and really humbled to be named to the top 20 women in Africa in cybersecurity, top 20 women of the world in cybersecurity in 2024. And beside my work, I'm a calisthenics player, so you can see me here doing some monkey bars walk. Alright, let's talk about the digital transformation of payment services. There is no doubt how digital transformation has changed how we live right now. We are connected more than ever. Using our mobile devices, we can send money to each other across continents. So it really has changed our life. There's no doubt about that. But on the other hand, the financial services is one of the most targeted sectors worldwide. As a result of that, the cost of the data breach this year has reached its highest value, reaching 34 million Saudi riyal. This statistic is across the Middle East, and it is by IBM Cost of Data Breach Report. Okay, this is what we are going to discuss today. We're going to talk about the key workflow in the payment applications. So basically, the workflow in payment applications, it's usually composed of these 3 steps. The first one is the customer registration and authentication. Moving forward is the AKYC-based process, and maybe it is electronic or as a normal one, but we're gonna discuss the digital one because we're gonna break it. And then the modern payment services. Okay, it's time to get our hand dirty and start doing some attacks. So this is the payment flow that we have just talking about. We'll be passing through every stage and do some interesting attacks. So the first thing we're gonna talk about, this will be our initial foothold, where we'll be performing account takeover. This is just the warm-up. And then we're gonna perform a fraudulent AKYC process. And then comes my favorite part, is stealing money. So these are the post-login functions. We'll be stealing money, we'll be breaking the limits of the buy now, pay later, and we will also perform fraudulent money transfers. Alright, I have been saying business logic vulnerabilities for quite a long time. Allow me to explain what our business logic vulnerabilities mean. So basically, business logic vulnerabilities, they are flaws in the design and the implementation of the applications that allows attackers to abuse a legitimate function to perform malicious actions. This is my favorite type of attacks because tools, with all respect to tools, they cannot detect these. It requires human intelligence to understand the business and understand how the application works and then abuse it. So this is my favorite type of attacks. And through our scenario, we'll be using Alice and Bob to demonstrate our hacking scenarios. I know Alice and Bob, you all know them. They have been using them for decades, but now they are not friends anymore. They have turned against each other, and it's a reminder to trust your friend, but not their devil. Alright, let's start by the first stage in the key application workflow. So, this workflow is like the basic one for the customer registration and authentication, or even account recovery. They all work around the same. So let's have a look at the first step. Okay, let's have a look at the first step where we have the user enter their mobile number and request an OTP value to verify their identity. At this stage, the backend server generates an OTP value to the user and sends it to the SMS gateway provider so that it can be delivered to the user mobile number. The user gonna receive the OTP and send it along to the backend server to verify their identity. And then the server gonna do some verification and return a successful or a failure response to the user. This is the basic workflow in just any application. We are interested today to hack this step. The step where the user enters a mobile number and requests an OTP. So what we are going to do, we intercepted that request using a proxy tool, and this is basically how the request looks like. As you can spot here, we are having a method name, and we are having some method parameters being passed to that method name. So the method name here, it's OTP generation mobile version 2, and there are some parameters that are being passed. The first one is type, the other one is SMS channel, and so on. So what I thought about in this step, okay, we are having a method name that ends with version 2, so supposedly this is the most secure version that they are using. What about version 1? What happened to it? So there's almost, or it's a common misbelief for the attackers that unused code won't be accessed if there is no direct application calls to the code. So I was trying to abuse that. So I did proper enumeration and I discovered that version 1 still exists. It just needs to be called using the proper parameters so that you can trigger it to work. So by enumeration, I built the correct request. So I have to inject the parameter here, you can see, it's called OTP. And by examining how does the application works, I discovered two things, two ways I can do accounting over. So the first one, I'm going to force the server to return the OTP value in its response. How that's going to be performed? By analyzing the behavior of the application, I found that when I send the OTP value, the OTP parameter with a null value, the server gonna return the OTP in its response. This is the first way. The second way, let's take it to a new level. The attacker is able to control the OTP value that is delivered to the victim mobile number. By this way, the attacker can just control the OTP value, meaning so the OTP is just useless right now. So here can you see in the OTP parameter, the attacker is inserting a value, and that value has been sent on the server side, which means the attacker can control the OTP value. And here, I was just sending this is a screenshot from the victim mobile number with the OTP that has been sent by the attacker. So at this point, Alice will take over both accounts. That was the first step. That was just a warm-up. Let's go to step number 2. This one it's good, but it's not my favorite. It will go to the favorite ones when you go to steal money, because stealing money is the best thing I love doing. So, step number 2, we are talking about KYC verification process. As we all know, some countries restrict its users from performing money transfers prior to completing the KYC process. So it's really essential and it must be performed. And we started seeing the adoption of the AI and the KYC providers. So we have some companies that perform KYC as a service to others. And this attack was discovered in one of the very famous KYC providers. And of course, it is solved before I disclose it right now. So let's have a look at this KYC process step. Okay, so the step starts by number 1, where we have the customer scan their passport. And using OCR technologies, the essential details going to be scanned. And then the next step is verifying the customer biometrics. At this step, basically, the customer going to take a selfie, and then using AI and machine learning, what's going to happen is that the algorithm going to crop that part from the selfie and compare it against that cropped part from the passport. Okay, so the algorithm going to crop that part. The algorithm going to crop that part, and gonna crop that other part and compare. If this equals to that, then this is the correct person, and we're gonna verify its biometric. I thought about, since the algorithm is only cropping a part, what about using a monochrome image? What does a monochrome image mean? It's like what I am wearing, all same color. So at this case, we're gonna trick the algorithm. So when the algorithm crops that part here, it's gonna be the same when he crops that part from the passport. So whenever it compares this to that, it's just gonna be the same. So by this way, Alice completed the process using Bob's identity without even being there. Then comes my favorite part, is stealing money. Now we have logged in into the application using account takeover, and we have completed the fraudulent AKYC process. It's time to steal some money. So these are post-login functions. So at this stage, Alice is broke, she doesn't have any money, and unfortunately she has lost her credit card. And the fee for getting another card, for the card replacement, is $200, and she just cannot afford that. So what Alice is gonna do, that's what we're going to see. She's gonna get her new credit card for free. How are we gonna do that? So at first, Alice logs in to the bank account just as normal and chooses the services she's interested in, which is the card replacement, and adds the account that the fee should be deducted from, and the date, and all this normal stuff, and press on submit. Then she's gonna intercept the submission request before it goes to the server. Alice examines all the parameters that is being passed in that request, and she just didn't find any parameter that specifies the value or the fee of that service. But she noticed something else. She noticed that in most of the parameters, not all of them, most of the parameters, the developer is using sort of a naming convention. Most of the parameters, they are starting like this. You see, there is form management, pH dot, and some value. It's not used across all the parameters, but it's used in some of them. So at this point, Alice made an assumption. What if I can predict a parameter name that can control the value of that service? And she prepared a list where she added expected parameter names and tried them against the application. And luckily to her, one of the parameters worked, and she was able to control the value of that service. And she changed it to 0. What is so special about this vulnerability or finding is that I discovered it using no tools. It was all mentor effort and thinking, and eventually we could get that service for free. Now another interesting scenario that's also one of my favorites is that we're going to hack real-time payments. So what we are going to do, we're going to exploit the mathematical equations of the send money feature. Alright? So again, Alice is broke, but Bob is a nice man after all, and he decided to help her. Okay, I'll send you some money, but the money would not be detected from Bob's account. So he's helping Alice, but his bank account balance will remain the same. How that will even happen? Let's see. This is a request that we are going to manipulate.